In this video, we're starting on page 3 of day 2, learning about derivative at a point. We've been given a function p of t. This function outputs the projected population of 18 to 24-year-olds in South Carolina from the years 1990 to 2025. It tells us that t is the number of years since 1990, and it does output population in thousands. So we want to find p of 5 and estimate p prime of 5. So in Excel, I've already created an input-output table for the function. I have in column B the function, the cubic, the third degree. I have ran my t-values from 0 up to 35 to represent 1990 through 2025. We're interested in finding p prime of 5. So remember, we're estimating a derivative value using average rates of change. So we're going to start at the given t, and we're going to go over to the right a little tiny bit. I chose 0.000001 units to the right, and then we're going to calculate the new y value at that input. So in column C, it will equal the original x value plus 0.000001. So it's little tiny bit to the right. I resized my columns so that it will actually show the points, the digits of the value. Drag the formula down. Again, resize your columns so that you can actually see the values. Next, I need to evaluate the function at that x value shown in column C. So, using the given formula, the third degree polynomial, column D will equal negative 0.015 times the value in column C, that x value, raised to the third, plus 0.88214 times that x value raised to the second, minus 12.857 times that x value, plus 427.6212. I drag it down. I do resize on my column. All right, and the last thing I do before I go on and find the average rate of change is I check. I make sure that my x values are just a tiny bit apart from each other. I see they are 12, 12.001, and I check that my y values are just a tiny bit away from each other, and they are. So it seems like I probably set that formula up correctly. Next, I find the average rate of change. Our average rate of change will be a good estimate of the instantaneous rate of change. And that means this average rate of change will be a good estimate of the derivative. To find this average rate of change, which is the estimate of the derivative, I do change in y over change in x, so equals, in parentheses, y2 minus y1 divided by, in parentheses, x2 minus x1, and I drag it down. And there we are. So these values in column E are good estimates of the derivative values at these x values. So for example, at x equals 3, a good estimate of the derivative is negative 7.969. Okay, so back in part A, it says estimate p of 5 and p prime of 5. So p of 5, I see in my table, is here. P of 5 is 383.515. And it says p prime of 5 is approximately negative 5.161. Now I rounded those values to 3 places because it tells me that the population is in thousands. So when I interpret this 383.515 really means 383,515 people. And an input of t equals 5 represents the year 1995. So in 1995, the number of 18 to 24-year-olds in South Carolina was 383,515, according to this model. Now, P prime of 5 equals negative 5.161. Again, that's a rate. Negative 5.161 over 1. It's a derivative value. It's a slope. It's saying if you increase a year, you will decrease 5.161 thousand, like kids or people between 18 and 24. And that's only happening at the year 1995. Again, if you notice in column E, those derivative values are changing. It's not a fixed rate of decrease or a fixed rate of increase in the population. This is only happening in 1995. So at that time in 1995, the number of 18 to 24-year-olds was decreasing at a rate of 5,161 people per year. Let's try it again with a different equation. So example 3 says we have this function r of p. It tells us the total revenue in dollars from selling widgets when the widgets are priced at p dollars. So you're plugging in the price, so in dollars per item, and it outputs the revenue you'll earn at that price. So we want to find R of 6.7 and DRDP at 6.7. So the derivative, oh, and that's a typo there, P equals 6.7. So in Excel, I have created already an input of 6.7, and I've put the function in here, 130,850 times the P times 0.92 to the P. Tells us if you plug in 6.7, you get out 501,449.23. That's saying when they price the items at $6.70, the total revenue they'll make at that price is $501,449.23. Furthermore, they ask us to estimate the derivative at that price. So again, to find a derivative, we should think about the instantaneous rate of change. And a good way to estimate it is to go over a little tiny bit from the input value and evaluate the function at that new input value. So I'm going to have a new x value, which is equal to this x value plus 0.000001, little tiny bit to the right, and I'm going to reevaluate the function, find the output at that new input value. So 130,850 times this new x value times 0.92 raised to that new x value. And we know that the average rate of change between these 2 points will be a good estimate of the derivative. So this estimate of the derivative equals, in parentheses, change in y divided by change in x. Always in parentheses. Change in y over change in x. y2 minus y1 over x2 minus x1. And it says that the estimate of the derivative is 33,031.52. Again, that's a slope. That's a rate. Saying at this price of $6.70, we have this slope, 33,031.52 over 1. That is change in revenue over change in price in dollars. So it's saying you go over a dollar, increase a dollar, they'd increase their revenue by 33,031 and 52 cents. So if they increase price to $7.70, so if they increase the price by a dollar, they could expect to raise revenue by $33,031.52. It then in part B asks us to do it again, but this time at a price of $28.20 per item. So I already have this all set up in Excel. All I really have to do is come over here and drag my formulas down. So now the new price that I'm inputting is $28.20. Tells me the revenue at that time is $351,430.59. Here I change this to create this new point that's a little tiny bit to the right, and it calculates the average rate of change between the 2 points. And I see this time that that average rate of change, that estimate on the derivative, is negative. So let me just jump right to it here. It says R of 28.2 is 351,430.59. R prime of 28.2 is negative 16,840.77. They're saying that at a price of $28.20 per widget, the revenue they earn is $351,430.59. And if they raise the price $1, they can expect revenue to decrease $16,840.77.